Hello friends, myself Ajay Agnihotri from Jawahar Navodaya Vidyalaya, Shadow. I am working as a PGT Physics. Today I am going to represent my video with the help of PPT. This opportunity is provided by NLI Ranga Reddy and RO Bhopal. I am very much thankful to them. In this pandemic session, we are in our lockdown position. So this is my duty to give some lectures, educational lectures, videos to you. Now I am going to start. Before starting, I want to ask some questions. What do you mean by force? Already we have studied before this. Force is a cause, external cause, by which if a body is kept rest, it starts motion like this. This is a metal ball. This is at rest state. If we release from this position, automatically it comes in motion. It means that it is experiencing a force. What is the name of force and who applies force over it? The earth only. And the name of this force is proposed by a famous scientist, Isaac Newton. He seen an apple falling towards the earth, and according to this interesting activity, he gave this idea, gravitation. This force is very much important in various natural phenomena, like moon revolves around the earth due to this force only. Earth revolves around the sun due to this force only. That's why this is very important force. And this law, which is proposed by Newton, is called Newton's law of gravitation. This is a universal law because this is applicable for all the bodies which are present in our universe and having mass. But if we take two bodies which are very, very small, then the force which is experienced by these two bodies is negligible. That's why always we have to take one big body like Earth. Another body we can take this or this. But first body we have to take very big body like Earth or Sun. Very big body has very big gravitational force applies over the body. Then the Newton's law of gravitation, which is proposed by Newton, this is an observational law. Newton observed so many phenomena and proposed this law. According to this, every object in the universe attracts every other objects by an amount of force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between these two bodies. According to this picture, M1 is the first body and M2 is the second body, and R is the radius distance between these two. Then mathematically we can write F is equal to capital G M1 M2 upon R square, where capital G is the gravitational constant. Its value is determined by a famous scientist, Cavendish, by using very sensible physical balance, and the value of capital G is 6.67 into 10 raised to minus 11 and its unit is Newton meter square kilogram raised to minus. The force which is experienced by a body due to earth is called gravitational force. Its value can be calculated by this formula. If M1 is the mass of the body and M2 is the mass of the earth, then by this formula we can calculate the force experienced by this body due to earth. this is an attractive force always, and these are equal and opposite forces. But Earth always attracts this body because Earth is a very huge body. So that's why this body will fall over the Earth. Earth will not be attracted towards this body because this force which is applied by this body over our Earth is not very much big to pull the Earth towards this. So that's why apple always falls over the Earth. Earth will not be moved towards the apple. This is the importance of this universal law of gravitation. Every object which are kept over the Earth bind to the Earth from this. We are also bind. If we take the jump, once again we fall over the Earth, binds us to the Earth. The motion of the moon around the Earth, the motion of the planets around the Earth, the tides due to the moon and the sun, all these activities are due to this gravitational force. Now free fall. A body which is falling freely under the effect of gravity, this is called free fall because only gravitational force is experienced by this metal ball. No any other force is acting over it. That's why this is free fall. We just release it. Then its velocity increases continuously, means its magnitude, the speed you can say. The speed of this ball increases continuously. That's why acceleration produces in it. The acceleration which is producing in this, it is due to gravity or gravitation. That's why this is gravitational acceleration, and it is calculated by this formula. If m is the mass of the body and r is the radius of the body, then we can calculate the gravitational acceleration. The gravitational acceleration of Earth is 9.8 meter per second square. This formula we can see here. According to Newton's law of gravitation, if capital M is the mass of the Earth, that is small m is the mass of the stone which is kept just over the Earth. This is Earth, this is the radius, and this stone or metal ball is just kept over the surface of Earth. The size of the stone is very negligible, that's why it can be ignored. Then this is the force which is experienced by this metal ball due to Earth. Capital M, small m, capital R is the radius, and according to Newton's second law, F is equal to ma. Here acceleration is producing in this metal ball is due to Earth gravity only. That's why it is called gravitational acceleration. Then we write F is equal to mg. If we equalize these two equations, then G capital M small m upon R square is equal to mg. Then small g is equal to capital G capital M upon R square. From this equation we can find out the acceleration due to Earth, acceleration due to Mars, acceleration due to Moon, etc. Every astronomical body has different gravitational acceleration because the mass of the astronomical body varies and radius of the astronomical body will also be varied. So that's why gravitational acceleration of Earth is different from gravitational acceleration of the Moon. Free fall, this is already over. For Earth, the value of gravitational acceleration is 9.8 meter per second square.